Hi, my name is Chris Gascoigne, and in this demonstration, I'm going to be showing how OpenStack, along with ACI and Puppet, can be used to provide end-to-end automation of an entire application. So in this demonstration, the application that we're going to be looking to deploy is WordPress, which is just an open source blogging application. In this example, we're going to be running WordPress on some Ubuntu-based virtual machines, and we want the application and the operating system to be configured by Puppet to go and automatically install the requirements of the application on the operating system and configure those services and configure the WordPress application itself. This application is going to be deployed onto an OpenStack based private cloud environment. So in this instance, OpenStack is going to be provisioning, we're just using local storage, but it's going to be provisioning network resources onto an ACI fabric, and it's going to be also provisioning the virtual machine resources onto the KVM hypervisor running on some UCS C-series servers. What we're doing on top of that is we also have OpenStack heat templates to describe all of the infrastructure requirements of the WordPress application that we're going to talk about. So in this instance, those heat templates are going to provision all of the network resources required for WordPress, all of the compute resources, and how all those things relate together. Before we get into the demo, one thing I just want to talk about is the style of automation that we get out of things like OpenStack. Traditionally, OpenStack with Neutron has exposed a lot of the network details to the OpenStack user, which is typically going to be the application developer. So the application developer would be expected to understand traditional networking constructs like VLANs, like subnets, VRFs, SBI interfaces, and so on, which is really not the level of abstraction that an application developer would prefer to use when talking about infrastructure such as the network. So what Cisco, along with a number of other vendors, did is proposed to the OpenStack community that a simpler, more abstracted model was required for provisioning the network by application developers. And so what came out of that is this idea called group-based policy. And group-based policy basically follows the architecture of Cisco ACI, where we take very simple groups of servers, such as virtual machines. So in this example here, we have a group of web servers, a group of database servers, and we apply policy between them. We say, these web servers are able to communicate with the database servers on port 1433, for example, or we expect them to communicate via a firewall and a load balancer, and so on. And so this abstraction is much simpler for application developers who are going to be the users of OpenStack to actually understand and build into their application code when they're actually talking to the OpenStack infrastructure. So let's get into the demo. First thing I'll do is I'll go across here to my OpenStack environment, and you can see that all I've got here is a standard Ubuntu OpenStack installation running across on a couple of C-series servers. What's new in here though is that we have under my project, I'm here logged into the admin project, and I have a new tab here called policy. And this is where we can actually create those group-based policy constructs through the Horizon web interface. So as an example of that, if I go here to the policy groups section, you can see there currently aren't any created for this project at the moment. I'm going to create a new policy group called test. I'm going to say that this new policy group test should provide the outside rule set, as in it should provide services to the outside of the network, and I'm going to choose leave it as the default network policy there. And so I press create, and you can see obviously here in the OpenStack side of things, I can see that new policy group is created and it's providing the rule set that we selected. What's interesting, what we have here though, is that in this case, the OpenStack environment is using the ACI group-based policy driver. So those group-based policy constructs that we build in OpenStack are mapped automatically down into the ACI fabric. And so here in my APIC GUI, you can see that I've got a tenant automatically created called admin, matching up to the project that I had in OpenStack. And what's being created automatically over here are endpoint groups, and bridge domains to match the policy groups that I created in OpenStack. And you can see if I refresh the graphical view here, you can see that that new endpoint group test is connected to the outside network via a policy rule set or a contract called outside. I'm going to go back here and just remove that one for now and validate that it got deleted on the ACI side as well, so everything's cleaned back up. And so we can build out all of the application's network policy through this group-based policy concept within OpenStack. So we can build out policy groups which map into endpoint groups on the ACI side. We can build out things like policy rule sets, which map into contracts on ACI, policy rules, which map into subjects on ACI, policy classifiers, which map into filters on ACI, so on. We can also, if we want to, build out layer 3 and layer 2 policies, which map into private networks and bridge domains on the ACI side. So effectively all of the ACI capabilities are exposed in OpenStack through that group-based policy concept. And we could do everything manually through the GUI in OpenStack, just like we could in ACI, and have a single interface to do everything from a compute and network and storage through OpenStack. However, what's really interesting with OpenStack is to actually look at how we can use it to automate entire application environments in one go. And in OpenStack, that's done through this concept of heat templates and using heat templates to go and instantiate entire application stacks. So if you see here at the moment, I don't have any stacks running at the moment on this OpenStack environment. What I'm going to do is I'm going to show you a heat template. So this here is a heat template that we've put together that basically will go and build a 3-tier web application using OpenStack's group-based policy, and the virtual machines that this template instantiates will actually then register with a Puppet master and use Puppet to get all of their operating system configuration, their packages installed, and the application code installed, and have all of those components configured. So I'll quickly take you through what this template covers. So this template is going to build out a whole bunch of resources in OpenStack. The first thing it's going to build out is a policy group, which is going to map to an ACI endpoint group. So we're going to build out a policy group called web for where our web interface, web servers are going to sit. Our web tier is going to sit. It's going to build out a policy group called app, where our application tier is going to sit. And it's going to build out a policy group called database, where our database tier is going to sit. And you can see here for each of these policy groups, it's actually choosing which rule sets should be used to apply policy in and out of those policy groups. Going down a bit further, what you can see here is it's also going to go and spin up a number of virtual machines. So we're going to go and spin up a web VM, an app VM, and a database VM. And each of these virtual machines, through their cloud config, is going to be automatically configured to have Puppet started and have that Puppet agent go and register with the Puppet master to get their application, the operating system configured along with the application installed and configured as well. And then the final things that this template goes and builds out is all of the policies between those groups. So down here, we're creating the policy classifiers, the policy rules, and the policy rule sets that are going to be referenced by those groups above. So we have, a rule set here for the web traffic, a rule set here for the app tier traffic, and a rule set here for the database tier traffic. And then finally, the output of this entire template is basically going to be the IP addresses of the 3 virtual machines that were created in each of those in those 3 tiers: the web server, the app server, and the database server. And so I guess what's really important about this entire template is that from an application developer's perspective, they don't really need to know anything about networking in order to build out this template. This template is literally just how the application is constructed and how the servers should talk to each other. They don't need to know which IP addresses are going to be used. They don't need to know anything about VLANs or VRFs or subnets or all of those traditional network constructs. So to show you this in action, I've got basically a very simple script that will use the heat CLI application in order to take that template and request OpenStack to go and build an instance based on that template. So if I simply start this script called start stack and choose the name of the stack that I want to use, in this case I'm going to say demo. What it's going to do, you'll see it's going to, here we go, it's basically taken that template that I just showed you, submitted that to the heat orchestration engine to go and build out all of those resources, and that stack is now in the create in progress state. If I jump back to the web interface here, we'll see the same thing. We'll see that my demo stack is currently in the process of being created. It provides a fairly pretty but not particularly useful view of all of those resources that were in that template and how they relate to each other. So we can see all of the different components of that template and their relationships. While that's happening though, what I'll do is I'll jump over here to the ACI APIC GUI, and you can see that immediately what's already happened is that the heat orchestration engine through Neutron in OpenStack has actually gone and already built out all of the networking resources for that application. So it's built out my 3 endpoint groups. It's built out the contracts that link those together. So the app, database, and web contracts have all been built out. And if I refresh this view here, we'll see, and I'll just rearrange this so that it looks a bit neater. We'll see that it's actually built out that entire application policy. So it's built out a policy that has the web servers able to communicate with the app servers able to communicate with the database servers via these contracts or policy rule sets, and all of those servers are able to communicate with the outside world via this outside contract as well. So if I go back, one last thing I'll show you on this web interface is if I go back here to the actual stack itself, one of the main thing I'm interested in here is the output of what are the IP addresses of the servers that were, or the virtual machines that were stood up, because like I said, none of that is statically defined, so these could change every time we stand up the application. So in this case, we can see the IP address of the web VM is 131.2. So what I'll do is SSH onto that. I'm just going to remove any old instances of the SSH key. Now I'm going to SSH to the web virtual machine, and you can see that that's now up and running. I should be able to ping to the application server, which was .10. Sorry, the database server is .10, which I shouldn't be able to ping to. The application server is .18, which I should be able to ping to. So we can see immediately that policy, the application policy that's being enforced in ACI, is being enforced correctly. I can ping to the application server, but I cannot ping to the database server because there is no policy to allow that. If I take a quick look here at the logs, we'll see that Puppet has been running. So Puppet has run. What it's done is it's installed HA proxy on this web virtual machine. So it's installed HA proxy. Looks like it's actually started configuring that HA proxy instance as well. What's also happening in parallel to this is that the app web server is having Apache installed and WordPress installed on top of that, and it's having, and on the database server, MySQL is being installed, and then Puppet is going and configuring all 3 of those to actually talk to each other. So to see how that's going, what I'll do is I'll go to my web browser here, type in the IP address of the web VM, which was .2, and you can see there we go. WordPress is installed and ready to go. So that entire application stack has now been installed and configured across all three um, of those servers in those three policy groups, with a security policy around all of them, to dictate which of those servers can talk to which other ones of those servers. What's really nice about this entire environment is that once we're finished with that, this particular instance of my WordPress application running on OpenStack, we saw how quickly that entire application can be created. That entire application can be torn down in effectively exactly the same amount of time. So you can see if I just run the stop stack script, it's basically just going to request that heat goes and removes all of the resources that are running that stack. And we can see that it's currently delete in progress. And in a couple of moments, if I jump back here to the APIC, you'll see that all of that network configuration is gone. If I go back to my OpenStack environment, it's all gone from here. My policies are all gone, and my compute instances are all gone. So, instantaneously, I've managed to stand up an entire application stack and then tear it back down again. And this speed with which we can actually stand entire application stacks up and down actually opens up a whole bunch of other opportunities, I guess, to application developers, where they can actually now start to use the real production infrastructure for their continuous integration testing, and then do continuous deployment workflows on the back of that. So as an example of that, to show you how that could work, what I've got here is that the template that I showed you just a moment ago, this template is actually stored in a Git repository, and that Git repository is in Gerrit. So it's got a code review workflow around the code that runs this application. That will do a couple of things. So the first thing is that if I make a change to that template and submit it to Gerrit for review, Gerrit will then instruct Jenkins, which is a continuous integration application or tool, will instruct Jenkins to run some tests on that change that's been made by the developer. So I'll show you that in action. So if I go back here to my three-tier web application template, I'm going to make a change to this. So I'm going to change the name of one of my my bridge domains here. I'm going to change the name to include the word demo. What I want to do now is I basically want to commit that change. So I'll say git commit. I'm going to say changed to demo. And then what I'm going to do is submit my change, that change that I just made, for review. So say git review. It's basically going to submit those changes that I just made into Gerrit. So if I go back here to Gerrit, we'll see that there's an open change request. So someone has made a change to the project, and it's waiting, I guess, to be approved to go into the mainline version of this piece of code. So you can see here, this is the change that's been requested. And then what's immediately happened is you can see down here in the history of this change is that Jenkins has made a comment to say that it has started a build based on this change. And so if I jump over here to my Jenkins environment, you can see it's actually kicked off a workflow in Jenkins to test that change to my application code, or the template that runs that application. So I'll go here to the console output and we'll see what it's actually doing. So you can see here that what Jenkins is actually doing is running my test script based on the changes. And what that test script is doing exactly the same thing as we would do in production. It's starting the stack on OpenStack, and it's then waiting for that stack or all the components of that stack to start up, and then it's going to test that the stack is working as expected. It's going to check that the web server responds with the WordPress installation screen. And so it'll take a couple of moments, but while it's happening, if we go back here to my OpenStack environment, we can see all of the instances that Jenkins stood up, exactly the same as what we just did in our production example, our web app and database servers. Um, it appears here as a stack that's running on OpenStack. All of the policy constructs are built out, so the proper web app and database and all of the relationships between them is provisioned there in OpenStack, and it's also provisioned over here in ACI as well. So we can see we have all of our endpoint groups, and once again it'll look exactly the same as our production environment where we have our, our our web tier, there's a web tier, our app tier, and our database tier, all all communicating with each other only through the contracts that we created. In this case, the app rule set, database rule set, and so on. So the whole point here is that our testing, we're running automated testing against any changes to the code, and that automated testing is being done on exactly the same set of infrastructure using exactly the same policies as our production environment. If we go back here, we'll see that the tests are still running, so we're still waiting for HTTP to finish starting on the web server. We can see now that the looks like the HA proxy is now installed and running on the web front end because it's accepting HTTP connections, but doesn't have any backend servers to service that request yet. So we're obviously still waiting for Apache to be installed on the web server, sorry, on the app server. And in a moment, the app server will be ready, and we'll get a standard, default Apache reply, and then shortly after that, we'll see that WordPress will be finished installing. So there we go, where we can see that the correct content was received, so the tests have all passed, and Jenkins is now, or the test script is now basically removing all of the configuration off the infrastructure. So we'll see if we go back to our OpenStack environment, we'll see that all of the policy groups have been removed. On our ACI fabric, everything's been removed, and it's now all finished. Everything's been cleaned up, ready to run the next test as soon as someone makes a change to the code, or ready for someone to deploy into production. One last thing, if we go back here to our open change set in Gerrit, we can see that once that test actually finished, what Jenkins did is it posted another comment into the change set saying that it has finished its test and the test was successful. And so what it's actually done is it's given the code a +1 review, indicating that it looks good from an automated testing perspective. What I'll then do is go and say, well, I've reviewed the code to make sure it doesn't do anything nefarious, and then submit it, and basically that change set is now closed and the change is now merged into the master version of this project. So hopefully that demo was interesting and showed you how ACI, along with something like OpenStack and with Puppet on the virtual machine side, and some open source tools like Gerrit and Jenkins, can provide a full workflow around application deployment, application lifecycle management, and allow customers to start working in that very sort of DevOps centric approach.